Hello, everyone. Today I will talk about how to approach code development, particularly front-end, to reduce the risk of project failure. I have already talked about some things, maybe some about myself. By the way, let's start with this. A little about myself. I've been in IT for quite a long time, 20 years, starting once with information security, then moving into development. Then I built my own business for many years, developed an outsourcing company to 150 people, completed many projects for various clients, including large pharmaceutical companies, Daimler, a total of 80 projects, 5 companies from the Fortune 500 list. For the last 3 years, I've been working at Google in the Google Cloud Serverless Cloud Run team. And not so long ago, I launched a YouTube channel, Viktor Turskyi on programming. I'm curious, who knows or has heard about this channel? Well, quite a few people who haven't heard. You can check it out, subscribe now or after the presentation. There I post things that I have talked about at conferences before or plan to discuss. But today there will be things that were in some presentations. There will be things that were in one presentation, and there will be things that I haven't mentioned anywhere, neither on the channel, nor at any other conference. And we'll start conceptually at first, then move on to more process organizational ideas. And at the end, I will even have code examples in this presentation. And actually, the first question is quality software even worth making quality, as it were? So, if we talk about quality, today we will discuss quality. There are 2 types of quality. The first quality, which is visible to our users, is how the product works. And there is internal quality. And today I am talking exclusively about internal quality, about how the code is structured or how well it is written for developers. And the first question is it even worth investing in this? Is there any sense in it? Or can we just keep hacking away? And when a problem arises, we fix it. A problem arises, we fix it. And generally the question is any architecture needed on the front end? Because I've heard different opinions. Who thinks that the front end needs architecture? Do you need to have architectural skills to be a front end developer? And who thinks that you don't need to have them? One person. In general, I'll tell you this. At Google, there isn't actually a position called architect, and you need to have design skills, but it's not necessary. No, to be an architect, it's not necessary to have an architect on the project, and design is an integral part of essentially developing any code. But often we hear this thing that we choose either quality or cheap. And we also have this triangle. Maybe you've seen it. Quality, cheap, fast. And you can't have all 3. You can only have 2 of these 3. And who has ever seen such a comparison? Quality or price? I think everyone has seen it, right? One person to everyone. And who thinks differently that this is incorrect? There is one person who thinks it's incorrect, but actually it depends on the domain. If we talk about software development, it's a strange situation because often poor quality is not necessarily cheap, meaning poor quality can be expensive, and in the long run, very expensive. Therefore, if we do it with quality, it often turns out to be cheaper. And I really like this quote that if you think the good architecture is expensive, try bad architecture. And the most popular, by the way. There's a great article called The Big Ball of Mud. And in this article, the authors nicely demonstrate the most popular architecture today, how it looks, how it works, and why it arises. But now, of course, the question arises, if we say that it's worth investing in quality, then from what point do these investments become justified? From what point? How long does a project need to be for the investment in quality to pay off? And this could be a year, 10 years, 5 years. But I liked a good article on this topic by Fowler. And he considers speed. That is, we have a graph where we see a curve showing the total number of features in the project, and over time, the number of features starts to grow more slowly, meaning it takes longer to add new and new features. Initially, it's fast, then it slows down. And this arises because of low internal quality. If the internal quality is high, then initially we are a bit slower, but then we add features at the same speed as at the beginning. And now the question is, yes, where is the boundary when we should invest in quality? And, well, at least from Fowler's research, it can be seen that this boundary is reached when our project lasts weeks, not even months, but weeks. That is, if our project lasts not just 2, 3, 5 days or a week, but weeks, then it makes sense to invest in quality. And if we are talking about architecture, of course, we need to design the architecture and make architectural decisions. And how to approach this. Yes, so what is the best architectural decision? And I really like Robert Martin's idea in this context, which says that the best architectural decision, Pota, is the one that wasn't made. Roman Burenko. Sounds like some kind of a nonsense, right? And there's a phrase, a quote from Robert Martin, and even a great talk by him on YouTube. I will leave a link in the slide. As Robert Martin says, the job of an architect is not to make decisions, not to take decisions, but to postpone decisions as much as possible. And good architecture maximizes the number of decisions not made. And what's the logic, right? It sounds somewhat absurd. Then what's the logic of this statement? The idea is that our architecture often, almost always, depends on our knowledge of the subject area. The better we know the subject area, the better we will design our code. And the fact that we, for example, have React or Angular, and we have some basic primitives, components, services in Angular or their store, smart components there, dumb components in React, some Redux. These are just basic primitives from which we still need to build higher level abstractions. And this is not sufficient. That is, to build everything well, we need to understand the domain. But at the start of a project, we practically never have enough knowledge in the domain. Roman Burenko, in other words, you could even say it differently. The further we go, the more information we have about the domain to make a better architectural decision. And an architectural decision is one that is difficult to change. Therefore, the later we can make a decision, the better it will be, because we will have a better understanding of the domain. And in connection with this, we have to, but we will still have to make some decision, right? Even at the beginning. And we need to build code that is constructed in such a way that it does not block any paths for the project's development in the future. And the question is, how can we make a better architectural decisions about overall? What I have already said is that everything we do, we solve the business or product problems, meaning our problems that we solve technically are usually within the product domain. And the product domain is essentially the business domain. And we are simply looking for technical solutions to business problems. And if we do not understand the product, if we do not understand what problem the product solves for users, we cannot offer a good technical solution. But if we do understand, we can often propose not just one solution, but several, and choose the most optimal one. Because when someone comes to you with some idea, product design, or another concept of how a user might use the system, it is not always the most correct path. Roman Burenko. Also, if you are offered a technical implementation, something that needs to be done, it is not always what is needed. But you cannot evaluate it until you understand the real problem behind it. And this is why it is important to understand the product, the domain in general, the subject area. Besides being a source of requirements, as I already mentioned, understanding the product significantly eases communication with all other stakeholders, such as product managers, product owners, management, and everyone else. That is, you communicate better, and it becomes easier for you to model these business concepts in your code. Moreover, it also affects the psychological comfort of developers. When I started in development, I thought all developers wanted to write back-end code, as it was the best thing. Then it turned out, no. Then I thought that all developers wanted to write some complex things, like super challenging tasks with difficult problems. And it turned out that no, many developers want to write, for example, online stores, B2B portals, or something else. But essentially, it's not about them wanting to write stores. They want to write what they understand. Roman Burenko. And when a developer knows the product they are writing, they understand it. They understand how an online store is used because they themselves are users of other online stores and they feel comfortable writing. But at some point, a client comes and says, let's implement, say, a logistics module. And suddenly, everyone feels uncomfortable. Because logistics is, for example, something that is usually hidden from the user. They don't see from the outside how it works. But if the developer figures it out, they immediately feel more comfortable. Therefore, I highly recommend understanding these. In the product domain, perhaps if you are a manager organizing some business training, not business, but training in this specific field. When we were developing an accounting system, there was a lecture on accounting every sprint. And I think without this, we would never have been able to write the accounting system. But with it, we were able to build the right abstractions in the code. And moving on. In general, I noticed that many developers have a solution. They come running with a solution and start from the solution, not from the problem. Roman Burenko. And once, an acquaintance of mine who was the head of data science at Uber in California, but he himself is from Ukraine, came to Ukraine. We were having a beer and discussing how to properly solve some business problems. He said, look, I have a method that I would recommend to you which will improve your solutions. And I want to share this method. It's very simple. First, you identify the problem. That is, if you have a solution, don't think about the solution. First, think about what problem this solution solves. And then consider alternative solutions. Well, and think about this problem. First of all, is it an important problem? Perhaps it's not a problem worth solving in the first place. But if it's an important problem and you identify it as an important problem, then think about several solutions. And several more can just mean one more solution, because many people are afraid. Yes, now I need to analyze all the solutions. You don't need all the solutions. If you simply add a second solution to the existing problem, your effectiveness in what you do and the quality of the decisions made will significantly increase. It's the same here, meaning in development, developers often come running, saying, let's add micro frontends, or WebSockets here, or something else. You always need to return to the problem, understand whether it's a problem or not, at least a few solutions, and then choose. And this principle works everywhere. So, as I already mentioned, the first thing is to better understand the domain. Second, understanding the technologies is important. For front-end developers, this is just as important as it is for back-end developers. And I have a great example from real life. Who writes in React Native, for example? Who has heard of it? Who knows approximately how React Native works? Oh, well, good. So I was interviewing a candidate. React Native is a framework for mobile development. You write in JavaScript, and then you get a native UI. Not JavaScript-based, not HTML, but actual native visual components. But there are limitations, because it's still JavaScript sending commands through a certain bridge to the native components. And some people think that there's compilation happening inside, but that's not the case. This also causes certain limitations because our JavaScript is much slower than the native code. And when you know this, you immediately understand the limitations. For example, we were working on a project that implemented end-to-end encryption, and we needed to generate keys. And it was clear that this wouldn't work properly because generating keys in JavaScript, especially on iOS without JIT in React Native, takes about 5 minutes. And the user is not willing to wait 5 minutes after pressing OK. But there we found our solution, launched it, used an iframe, a web view with an iframe. No, just a web view as a web worker, essentially. And there JavaScript with JIT was already running, and everything worked 10 times faster for us. And just the idea, well, what's the idea here? If you don't understand the technology, then you can't make decisions. You can't choose the technology. And you have two options when you encounter a technology. You can either read the marketing materials or read the technical materials, figure out how it works internally, and then you'll understand the properties of this technology. And understanding the properties is necessary to make the right decision about whether to use it or not. That's why it's important to understand the technology. This is very useful in many aspects. And not only on the front end, and not only on the back end, let's say. Moving on. I always wanted to ask Babic a question, but never did. However, there was a great thought from Serhi that we shouldn't do what we don't need right now, meaning what doesn't solve any problem. And on one hand, it's a good answer, but in my opinion, it's incomplete because you should always expect that a new requirement will appear tomorrow. And not so long ago, I was talking with my developers at Google. So we had this kind of session discussing Agile in general, the Agile Manifesto. And there was such a statement. Well, why do we need this Agile Manifesto if the Agile Manifesto already contains such obvious things that everyone already knows and understands? And I say, look, there is one of the principles, and I quote it right here, that we should welcome changing requirements even late in development. And everyone started to think about it, because many developers do not like this. That is, many developers, when we are, say, finishing a project, and the product manager comes and says to rewrite everything, or, well, not exactly to rewrite. He says, we are solving a different problem now. This is bad. But if we even look at the principles of Agile, this is something we should welcome. This is because at some point, the product manager also began to understand the problem they are solving better. And accordingly, we need to be ready for this. And how to be ready for this? First, you need to anticipate these changes. And the most incorrect way to be prepared is to try to write code that can do everything that is super versatile. Because if you write super versatile code, I even had this in practice back in 2007 at MailUA, we wrote a system that could do everything. But when a requirement came from the product team, it turned out that because this system was designed to do everything, it couldn't accommodate the feature that was actually needed, and we had to just discard it all and rewrite it in a much simpler way. But well, you have to think about what the product should be in the future. And the question is, can we somehow predict the future at all? And one of the good ways that I see works is to talk with product managers. That is, developers who communicate with product managers have a better understanding of what might happen with the product, because product managers live in the future. They are already, you are working on tasks they thought about yesterday, and today they are thinking about the tasks you will have tomorrow. And it's better for you to know about this, because you will be able to design your code better if you know what to expect. And well, you could say the basic requirements, you need to understand all of this. And let's assume you already understand all of this. You have the requirements, you are ready to launch the product, and I want to share a real-life example. And another approach that has worked for me multiple times, both at Google and at WebbyLab before this. On the screen, currently was a product for Mercedes, a kind of marketplace where you could rent a spot in a racing team, so to speak. And it's quite a complex system where we see there are requests, offers, cars, a gallery, and in the offers you can have discussions, a chat, and so on. So there are quite a lot of functions, and it's quite a complex project that needed to be launched as quickly as possible. And the standard approach, and we actually started with this, which the managers, what do managers try to do? When they receive the task to deliver it, they try to do the following. They don't try to break down this project. Well, first, they try to add more people to the team. We add more people to the team and think that we will do it faster. Okay? We have more people, but now we need to somehow parallelize the work. The next thing they try to do is break this project into some pieces, into pages. One developer is working on, say, the scam section. Another developer is working on the gallery. A third developer is working on the page with inquiries about scams. And a fourth is working on, say, the chat, or pages or components. This is all divided up, and the manager thinks it will work. And in practice, who has encountered this approach? Roman Burenko, yes, 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 and everyone thinks that it will work, and it's, let's say, unimportant to do this, but it's not enough. Because when you start working on all of this, it turns out that one developer is laying out a page, just like that, without components, just laying it out, while another is creating some components. Then it turns out that these components somehow need to be, or the pages need to be connected in the end. Then it turns out you can create common components. Then some start waiting for others, because this synchronization point arises. Because, okay, we have an offer, there's a widget for the offer, so let's have someone write it, we'll wait, and so on. And one thing depends on another, and besides, when we finally start everything, well, as if all these components are ready, we start to glue them together, they don't fit together properly. Roman Burenko, and we, for example, missed something in the user scenarios. In our case, it was like this. The user, okay, makes a request, and then, in the end, receives an offer. And then what? What happens next? It's unknown. Or there were some problems with registration simply because it wasn't fully thought through, and it's not always possible to think everything through. And we can start. Let's kind of start design everything first, and then begin writing. And this also doesn't always work well, because you can spend a super long time in this designing phase, waste a lot of time. And it's not guaranteed that it will all come together in the end. And what worked for me is the approach where we first try to gather everything. Yes, we do this designing, but our primary task is not to get the final components that we will assemble, but to first gather and then implement the component. That is, we need to create abstractions, like one widget, second, third, fifth, and directly write this on the page, place it in the code. It should look beautiful, we need to connect everything, and it should work. Roman Burenko. So for example, instead of a beautiful diagram, you might just have an area on the page where you simply do a JSON dump of the structure you want to show in the diagram, but you will have some component, some abstraction that accepts this data. So you start thinking about how data will flow throughout the project and connect them. Additionally, you have some input and some output. For example, in a diagram, you know that someone might click on an element and and it gets selected. And another part of the system needs to know about it. You also design this, but you just have text. You have, as it were, the most primitive page possible. This is very similar to the approach of drawing, like painting a picture. You don't start painting by telling one person, okay, you draw the leg, you draw the head, you draw something else. And then they all draw as detailed as possible, and then look at this picture. And, well, the head is there, the leg is there, the arm is there, and somehow, well, you can, yes, finish it. Like one arm is longer, the other is shorter, and it doesn't really work. Roman Burenko. Therefore, it is advisable to start by gathering everything together and then add details. And in this case, you will see from the very beginning that what you designed, you actually under-designed, because only the real work, when you launch something, shows whether it works or not. And when you start assembling these components, you will see that something needs to be changed in the abstractions, and you will start changing it, and it will be better. It's better to do this at the beginning than at the end. Besides that, you will get working, functionality from start to finish. And the product team will be able to click through it, and you will receive feedback on it earlier. Next, for example, for instance, there is an offer, and you need an interface that allows you to create an offer. Something very simple. Practically just squares that allows you to create an offer. However, later on, this offer, the person who implements the list of offers can already rely on real data. Because designers often draw one thing, naked, but when you add real data to the system, it looks different. Next, you can integrate with the backend much earlier. Practically immediately, because you will be pulling this data from the backend, and the backend developers will be able to modify their own API much earlier, check that it works as it should, and solves the necessary problems. And if you don't have time at the end to complete the entire project, then you will sacrifice not by having unconnected components, but by having some components that are not fully developed. And I made an example with cats to make it clear. So it's like we're drawing a cat, starting with the simplest form, then adding details, and in the worst case scenario, we end up delivering a cat that's halfway done. And if we compare the two approaches, it turns out like this. We can deliver the cat on the left, or a fully detailed cat, but the one on the right. And actually, this is not what our users want. And here, the question is, will this help us, right? So, yes, we can now mitigate this risk. If we don't manage to finish, we will still end up with a working product. But this also doesn't guarantee that we will manage to do everything. And we need to prioritize. And, for example, at Google, the standard approach to prioritization is P0, P1, P2. P0 is what we cannot release without. P1 is what we would really like to have. P2 is what we will do if there is time left. And when you go to the product manager says everything is important. Everything is important, meaning this is the top priority, and this guac, and this. Everything is important. Sometimes a question like this helps. I ask, if we don't manage to do this, do we cancel the release? He's like, well, no. Well, then, that means it's not P0, it's already P1. And if we don't manage this, do we cancel the release? Well, if it's this, then we cancel. Well, that means it's P0. And so, you need to extract this information. And if you look at it, in the context of a cat, it might look like this. The whole cat is all the tasks, P0, P1, P2. If the tail is our P2, well, yes, according to the second picture. And P0, P1 are what we would like to launch. But even in the most extreme case, well, we at least have to show the head of this cat, but making a cat without a head is not an option. Next, abstractions. An interesting thing about abstractions. Engineers are not only the... Even Google has a problem with this. The less experienced people have, for an engineer, the fewer skills they have in design, and learning to design properly takes time. Therefore, it is advisable to start designing from the very, very beginning. That is in Google, for example. Everyone designs their task from start to finish, starting from juniors. That is, a junior receives a task, still designs it, writes a design doc, and gets feedback from all the team, and so on. And in this skill of designing, skills need to be developed. And regarding abstractions, what is important? It's important that they are simple, so that when you throw this into the code, you look at this code, and it becomes clear to you that it works. This is a good mechanism. to improve code quality. Because, for example, if we talk about tests, it's like you can write code, write tests, and guarantee that it works. In reality, tests are just a statistical confirmation of the operation of a certain part of the functionality, but not all of it. It's just a small subset or sample from the entire set. And we think that the entire set, the set of switches works, and we can get either red or green. But working with such code is very difficult. That is, our abstractions should be such that we can fit them in our heads. When we see the code, we should understand it. Moreover, it's important that when we create new abstractions and write new code, we need to understand where this code will go. For example, we are writing, I don't know, validation, but like validation of something. We need to clearly understand that we have a place in the code where we should place this validation. If there is no such place, we need to think about where it should be. And it should be systematic and consistent throughout the entire project. There is also such a thing as the coupling and cohesion. This could actually be made into a separate lecture. And this is really a cornerstone of design. But what I've noticed is that developers are afraid to create new abstractions, especially those who don't have much experience. What do developers do? They either add code to existing files, INDE, or copy files and make files in the same format. And never, well, not never, but very often they feel uncomfortable adding an abstraction that didn't exist in the code before. I have a few stories on this topic. The first story, for example, we had a project, and in our project there is a test factory class that allows creating a test environment there. Add users, add some, well, depending on the project, that is to set up the database. And we needed to add, and we were using Chai as a library for assertions, and we needed to add a new assertion for date verification. We had a date in this format and needed to add this custom assertion. Alexander Okremenko and the developer looks and sees there's no file to add the assertion to, so there isn't one. He's like, well, fine, I'll add it to this test factory because the test factory is accessible everywhere. He can write test assert date and everything, is fine in the code for him. But this is exactly an example of what not to do, because it was necessary to simply allocate, create a new abstraction module, where even if you place just one method, it needed to be done. Another example, also from real life, about we were creating a PowerPoint for pharmaceutical companies. And I wrote a proof of concept where you could add various shapes, like a rectangle, a circle, and others, rotate them, all on React. So, a slide that you could work with to create a simple presentation. I wrote this proof of concept, which took me about 100 lines of code or so to work with the slide. Various widgets that could be added, and then I showed it to the team and handed it over. They said, well, it's okay, basically, we can implement this because the proof of concept works. And I come back 6 months later to look at the project, and that file has become 5,000 lines of code, everything like that. Alexander Okremenko. And it's not just that I came there. The developers called me, saying, damn, we can't work with this anymore. I come and say, what's going on here? Well, you did it this way. You made this file, this structure. I think, well, back then, the circumstances were different. It was a proof of concept. If you see that more complex behavior is emerging, you introduce new abstractions, and often developers just feel uncomfortable implementing and adding these abstractions. Similarly, in React, when you write, or in Angular, you have services, components, but adding some controller, well, we don't have controllers or a manager for something anywhere in the project. Why do we need it? And so people don't even know where to. They're like, I even had such a discussion with friends. So we have some functionality, where to fit it in. It doesn't fit here, it doesn't fit there. We try to squeeze it in here, but it turns into something unclear. I say, well, create a new abstraction. Yes, is that possible? Alexander Okremenko, well, is it possible or not? So the next thing is builders. Now I will go into more detail. We still have a little time left for this. For example, you have some kind of grid, like a grid O with some configuration. And it's quite a low-level configuration where you add a lot of things to it. And it's some library from NPM, you use it, ma. And then this grid, you have it on the first, second, third, fifth page. And you describe this configuration for each page in terms of this grid, meaning you use its syntax instead of creating some abstraction, a wrapper around this grid, which would allow you to describe the configuration more high level for the grid and place some behavior into a builder. For example, errors are returned from the backend, and they are always handled the same way. You know how they are handled. You can create this builder, this additional abstraction on top of all this, and significantly simplify the initialization of the grid. And now I would like to go over the concept of these builders, because not so long ago, I used them in one project, and they helped me very, very, very much. Helped, and the concept is somewhat similar to how in games, when you develop a game, you can write an engine, and then you can write a level editor, and you have the level editor separately. It serializes the level into some structure, and the engine separately. And builders are a similar story. And yes, we have universal, well, tools there for grids, admin panels. You might have a tool in the company that you use on all projects, and for building admin panels. And you think, well, it's good that it's difficult to develop. You have it, you should use it. If you don't use it, you are writing purely custom code. And now the question arises, is there a point, for example, in creating some kind of framework for admin panels or a UI framework within a small project? And actually, there is a point in this. And these builders essentially are this framework. And I wanted to show an example of what I often use. This includes form builder, dialog builder, grid builder, page builder. That is, for example, if you need to create a form, you can make a wrapper around an existing tool, but choose a scheme that works for you. Moreover, it will be easy for you to modify it because it is used only in one project, and you will add only what you need, and it will be as simple as possible. For example, you can say that you have an API to methods to load data, save. You have some inputs in the form, and then you can create, for example, a user edit form, some component that renders and loads user information, like this. And you can even do something more clever. You can create a dialog builder that will take the schema of this form and build a dialog for you. And essentially, you will have such a declarative description of the interface. And as soon as you change something in one place, like the type of dialog or how it looks, it will change everywhere because you have these abstractions. Moreover, as I already mentioned, you can create a grid builder. And in this example, we see these columns described. And here we have two fields, ID and name. Yes, so this is a list of users. There is a username and a user ID. And we have the ID type. And we can, since this ID type is specific to our project, we can convert it in a specific way into a set of low-level parameters for the grid we are using. There, a certain width, perhaps it is always a clickable link. That is depending on the approach you have on the project regarding UX. And for example, the name can also be like this. It can always be a URL. And so you can add a URL type. You can even add more high-level types. But what is also interesting here, for example, in each row there can be an action that can be performed in this grid. And you can also come up with a scheme to describe these actions as simply as possible. That can be done with a row.
For example, here we just have two actions. We see that we have an icon field. This is an icon, and there is an interesting confirm true. This, for example, means we know that for a certain operation, there must always be a specific type of confirmation. And this can be an additional library outside the grid that you use. But the builder will combine all this together, and you say, confirm true. This means that there is always a confirmation for this action. Also, the previous Almade dialog that we created with this builder, we use here when editing. We have some dialog service. We say open, pass all the information, and it works. This dialog can be invoked in different places. Moreover, this dialog can potentially be built to be fully custom. That is, today we build with the builder, tomorrow without the builder. But since we have a more or less universal abstraction, everything is fine. Everything turns out cohesive. And we can even go further and create a builder for the entire page, where we pass a layout, for example, a prop, selector for the selected user. This means that we probably have a key menu somewhere in the layout, and we need a menu item to be selected. We can pass the grid schema here, or we might not even pass the grid schema. We can pass the instance itself, well, the instance of the builder, for example. That is, depending on how we want, we can design it differently, and can this API constantly change. It's very quick, because we still need to write this code. We still need to create all these pages. And if we put in a little effort to work with abstractions, it will be easier for us. And then it will also be much easier for us to refactor everything, because refactoring is almost always either updating abstractions or updating implementations. If we recall Serhii Babic's presentation, all, the refactoring there boiled down to refactoring abstractions, while the implementation remained the same. If from the very beginning we use abstractions in a more or less simple way, everything will be okay. Moreover, regarding abstractions, I will now say the following. I see here 0, 0, 0, 0. That's it. Moreover, in terms of abstractions, when you write code that is easy to maintain, you need to write code that is easy to change, meaning it should also be easy to understand. Yes. In principle, I have a couple more slides, but I'm not sure if there's time. Shall we continue? The last thing I might say about technical debt. Some people think that technical debt is bad, while others don't think it's bad. But I really liked it. And there are different, various approaches to understanding technical debt. Some say that technical debt occurs when we just try to do something faster, and it didn't turn out as high quality as we would have liked. And then we need to sort of pay it off with interest. Sometimes technical debt turns into something like technical pollution. This is when, throughout the project, with each sprint, it gets worse and worse. But there is no specific point where we can fix it. But I also really like the idea that technical debt is not always bad, because it's like cooking. When you cook something in the kitchen, you can't prepare it without dirtying the dishes. And in the end, you need to wash those dishes. So if someone tells you that you wrote it like this, but it should have been written very well from the start, it's not necessarily true. However, you need to know that you have to wash those dishes and include that in your plan. That is, you first write, try to make it work, and then improve it over several iterations. Then you clean it up, remove the unnecessary parts, and tidy everything up. So it's like washing the dishes after yourself. Well, that's basically it, I think. Yes. Thank you.